Zeros of a quadratic function is an important topic which plays a huge role in IB mathematics. In this video, we're going to answer some of the most asked questions, some of the most important questions, including what it means when we say a number is a zero of a quadratic function, and how many zeros a quadratic function typically has, and also what we should do if we want to combine the zeros of a quadratic function. For example, like if we want to add the numbers or if we want to multiply the zeros, what do we do other than just adding or multiplying the expressions directly? Is there a better solution? We're going to find out. Hi, this is Tim from Premier Tutor. A specific value of x is a zero or a root or a solution of a quadratic function when this number can make the entire expression zero. For example, if you take a look at this expression here, f of x equals ax squared plus bx plus c, which is the general form of the quadratic function, then the value of x that can make this expression zero is called a zero. It's called a root or a solution of the quadratic function. And typically, a quadratic function would have two roots or two zeros or two solutions. If you take a look at a graph here, actually there are three random quadratic functions here. The first one at the upper left corner, it has two real roots because it intersects the x-axis at two different points. That's why it has two different roots. And these two roots are actually real numbers. And for the graph at the upper right corner, you can see that the graph actually touches the x-axis at only one point. For this situation, you can see this graph only touches the x-axis for one time. So then we say the quadratic function has one root, or you can say it has two roots. It's just the two roots are basically the same number. We also call it double root or double zero, something like that. It's just one number, but it still counts as two zeros. And the third situation, which is the one at the middle at the bottom of the graph, this graph actually doesn't touch the x-axis at all, which means it has no real solution. In fact, it does have two solutions, but these solutions are complex numbers, so we don't discuss complex numbers in this lesson right now. Now let's consider the general quadratic equation ax squared plus bx plus c equals 0, whose roots are alpha and beta. As you can see here, ax squared plus bx plus c equals 0, right? This is the quadratic equation, the general quadratic equation. But since the roots are alpha and beta, we can also write it in the form x minus alpha times x minus beta, and then this is equal to 0. Okay, and then let's just expand the x minus alpha times x minus beta, where we get ax squared plus bx plus c equals x squared minus alpha plus beta x plus alpha times beta. So if we equate the coefficients of both sides, you could easily say that alpha plus beta is actually just equal to negative b over a, and then alpha times beta, the product of the two roots, is just equal to c over a. So basically this is how we're going to add and multiply the roots together instead of just multiplying or adding the expressions of the roots, because sometimes that could be really tedious. It would be a lot easier if we could just use the coefficients of the quadratic equation to find a product, to find a sum. Now let's take a look at the following example. Given that alpha and beta are the roots of the given equation, find the sum alpha plus beta and the product alpha times beta of the roots. So for this kind of equation, the first thing we need to do is to identify all the coefficients a, b, and c, and then we should just apply the formula we just learned. So for question number A, we have x squared minus 5x plus 3. It's not that hard to identify that the value of A is actually just equal to 1. The value of B is equal to negative 5. Don't forget the negative sign. And also the value of C is then equal to 3. So the sum of the roots, alpha plus beta, is equal to negative b over a. And since b is negative 5 and a is 1, we just put the numbers in. Negative of negative 5 over 1. And this is equal to 5. Alright, so this is the sum of the two roots in the first question. And the product of the roots, alpha times beta, is then equal to c over a. Right, it's then equal to c over a according to the formula we just derived. And the value of c is equal to 3 and the value of a is equal to 1. So the answer is 3. The product is equal to 3 and the sum is equal to 5. For the second question, number B, we can see that A is equal to 3, B is equal to 4, and then C is equal to negative 7. So the sum of the roots, alpha plus beta, is negative b over a, and b is 4, a is 3, so the sum is negative 4 over 3. Finally, the product of the roots will be c over a, where c is equal to negative 7, a is equal to 3, so the product of the roots is equal to negative 7 over 3. This is how you find the sum and the product of the roots for a given quadratic equation, simply by identifying the values of a, b, and c, the coefficients of the quadratic equation. Let's move on to the next one. For the second question, we're given that alpha and beta are the roots of the equation 2x squared plus 6x minus 5 equals 0, and our goal is to find a quadratic equation whose roots are 2 alpha and 2 beta, and 1 over alpha plus 1 and 1 over beta plus 1. So this one is a little bit more challenging than the previous one, obviously. Let's find the sum and the product of the roots first. So for the original quadratic equation, we have a equals 2, b equals 6, and c equals negative 5, which means alpha plus beta can be found quite easily. It's negative b over a, and we know that b is equal to 6 already, a is equal to 2, so alpha plus beta is equal to negative 3. Also, alpha times beta is equal to c over a, which is negative 5 over 2. So these are alpha plus beta and alpha times beta. Next, for question number A, it's about 2 alpha and 2 beta, right? So let's see the 2 alpha plus 2 beta, the sum of the roots of the new quadratic equation is equal to 2 times alpha plus beta. So obviously we already know that alpha plus beta is equal to negative 3, so 2 times alpha plus beta is just negative 6. About the product of the roots of the new quadratic equation, we have 2 alpha times 2 beta, which is 4 alpha beta. So the product of the roots of the new quadratic equation is then equal to 4 times alpha beta, which is negative 5 over 2. So the answer is supposed to be negative 10. Therefore, the new quadratic equation should take on this form: x squared minus alpha plus beta x plus alpha beta equals 0. So it's x squared minus 6, so it's plus 6, plus 6x, and plus alpha beta, which is minus 10, equals 0. So the new quadratic equation is x squared plus 6x minus 10 equals 0. Let's move on to the next one. For number b, we're having an even more complicated set of roots, which are 1 over alpha plus 1 and 1 over beta plus 1. So let's take a look. For number b, 1 over alpha plus 1 and 1 over beta plus 1, if we try to figure out a sum of them, it would be 1 over alpha plus 1 directly at 1 over beta plus 1, and I believe you know how to combine the two fractions. You find their common denominators. That would be alpha beta plus 1 plus alpha plus 1 divided by alpha plus 1 times beta plus 1. The numerator is alpha plus beta plus 2, alpha plus beta plus 2, and for the denominator it is alpha beta plus alpha plus beta plus 1. Okay, so according to the numbers we have found already, alpha plus beta is just equal to negative 3, so negative 3 plus 2 is negative 1. So for the denominator, alpha beta is negative 5 over 2. We have negative 5 over 2 here, and add alpha at beta, so that would be negative 3. Negative 3 plus 1 is negative 2, so this would be negative 2. So negative 5 over 2 minus 2 is the denominator of this fraction, which is negative 9 over 2. So the final result is supposed to be 2 over 9. This is the sum of the roots. And then let's move on to the product. As for the product of the roots, it's 1 over alpha plus 1 times 1 over beta plus 1. So it's actually quite similar to the sum of the roots. It's just we're not having that same numerator this time. So the numerator is 1, but the denominator is still the same thing as before, which is negative 9 over 2. Let's just write it down, negative 9 over 2. So the final result is negative 2 over 9. So negative 2 over 9 is the product of the roots of this new quadratic equation. Now that we've got the sum and the product of the roots of the new quadratic equation, we can then assemble the numbers to get the quadratic equation itself. So the final result, we would have x squared minus alpha plus beta, which would then be negative 2 over 9, minus 2 over 9x, and then minus 2 over 9 equals 0. This is the new quadratic equation. Or if you want, of course, you can also simplify by multiplying 9 to both sides of the equation. In that case, you would obtain 9x squared minus 2x minus 2 equals 0. So this is how you come up with the form of the quadratic equation when the roots are given. Let's just move on to the final example of our lesson today. For the final question of our lesson today, I would say it looks a little bit similar to the one we just did. So why don't we just dive right into this question. Given that the roots of the equation x squared minus 4x plus 2 equals 0 are alpha and beta, find the values of the following expressions. So for part A, we have alpha squared plus beta squared. So how do we find alpha squared plus beta squared given the original equation x squared minus 4x plus 2 equals 0? So still the first thing we need to do is to identify all the coefficients and find out the sum and the product of the roots of the original quadratic equation first. The value of A is 1 and the value of B is negative 4. And also, let me just write down the numbers. A is 1, B is negative 4, and also C is equal to 2. So first of all, alpha plus beta can be found quite easily. It's negative b over a. It's negative of negative 4 over 1. So the answer is 4. Alpha plus beta is equal to 4. And then alpha times beta is c over a, which would be 2 over 1. So it is equal to 2. Now that we've got the values of alpha plus beta and alpha beta, we can start doing some algebraic manipulation. Notice that alpha squared plus beta squared is actually equal to the square of alpha plus beta minus 2 alpha beta. This is because the square of alpha plus beta is equal to alpha squared plus 2 alpha beta plus beta squared. If we subtract 2 alpha beta from it, it would then become alpha squared plus beta squared. So we already know the value of alpha plus beta, which is 4, so this is 16, minus 2 times alpha beta, which is 2 times 2, so that we can obtain the value of alpha squared plus beta squared. Now let's move on to the second part. For part B, we have 1 over alpha squared plus 1 over beta squared. So if we combine it together, this would then become alpha squared times beta squared at the bottom of the fraction. And then at the numerator of the fraction, we have alpha squared plus beta squared. According to part A, we have obtained the value of alpha squared plus beta squared, which is equal to 12. So let's just copy that number here. And for the denominator, we have alpha squared times beta squared, which is just the square of alpha beta. The value of alpha beta is equal to 2. So this is 12 over 4. So the answer is 3. So that's how you find the value of 1 over alpha squared plus 1 over beta squared, simply by some algebraic manipulations. With these 3 examples provided, I hope you have got some idea of how quadratic equations work and how to manipulate with the roots, whether to add them or to multiply them or some more complicated combination of them. And also, I hope you have understood why a quadratic equation could have 2 real solutions, 1 real solution, or no real solution. But IB math is so much more than it. It's not just about quadratic equations, it's not just about the roots and how to manipulate with them. So if you have any specific topic that you're interested in and you want to see us make a video about it, feel free to send us a message or comment below. Let us know what else you want to see. And if you find this video helpful, don't forget to leave us a like, share this video to your friend, and also don't forget that we're rolling out lessons during the summertime. We have AP lessons, we have IB lessons, even IGCSE, even A-level lessons, and of course the TOEFL, the IELTS, so much more coming up. And yeah, that's basically about it. If you're interested in anything mentioned previously, the only thing you need to do is just to send us a message. And as always, cheers, I'll see you next time, goodbye.